So we're looking at section 4.6, and this is the section they call special products. And so what we're going to look at are, let's see. Well, there's a couple of these. They've got a couple. I'm probably going to, well, they're going to show you two. One of them kind of doubles for, there's another one that it's usually done more explicit, but the first one I'm going to show you, these are going to be the special products. The first one, a plus b squared. Now, what we're going to do, we're going to FOIL this. Now, the way you could think of this, to get this ready for foiling, a plus b squared means you have an a plus b times let me wait for my camera to come back. There we go. All right, there we go. Sorry about that. Look at the camera went out for just a bit. So we're going to multiply the first terms of each binomial. So that's a times a. The outer terms of the product, a times b. The inner terms of the product, call that b times a. And then the last terms of each binomial, that's b times b. And so that's how we do FOIL. So when we add these together, and we always add them together, we get a squared plus ab plus ba plus b squared. And a key point with this is a times b, b times a. You could think of it as 3 times 5, 5 times 3. Both of those will give you 15. They give you the same thing. So we could just rewrite this as a squared plus ab plus ab plus b squared. And so we're going to get a squared. And we combine like terms. We have 2 ab's plus b squared. And this was equal to the original product. I erased, but it was originally equal to this. So that's our first special form. And this kind of doubles for a second one. And I'll show you what the second one is. But we'll take a look at some examples. So any questions about that? All right. So let's take a look at an example. Now, the idea of these special products, they're patterns that we don't have to fully FOIL things every time. We can come up with a shortcut. So for this, X will play the role of A, And 2 is going to play the role of b. So we bring out our formula. And we replace a, or substitute a, with x. And we substitute b with 2. And so this will become x squared. 2 times x times 2, well, the 2 times 2 is going to become 4. That's 4x plus, and 2 squared is 4. And then that's going to be our answer. So again, the idea is that this is faster. With these special forms, we can compute them faster than with FOIL. Questions about that? So let me show you another one. Now, in this one, when we have a minus, we can rewrite this as plus a negative. So this is kind of the second form, or the second version of this first form. And sometimes you'll see it presented as, well, we have a plus b squared, let's look at a minus squared. But you can actually combine these two. If you take the minuses, rewrite them as plus a negative. And so 2m will be a, and negative 7n will be b. So for a squared, we'll have 2m squared. And then 2 times 2m times b, which is minus 7n. That negative sign goes with the b now. Plus b squared negative 7n squared. So what we'll do here, we're going to distribute the exponent as an exponent. Well, any questions so far? Excuse me. So if we distribute this exponent as an exponent to each of those terms, we'll get 2 squared m squared plus, now let's take a look at this one. 2 times 2 is 4 times negative 7's negative 28. You have m times n. And then here again, we're going to distribute that 2 as an exponent. And so this will give us 4m squared. Adding a negative, we're just going to turn it into a subtraction now. Minus 28mn plus, now negative 7 squared. So that's negative 7 times negative 7. It's 49 n squared. So questions about that? All right. So that's how we work with the first form. And again, the first form kind of lets us solve two versions of this, when there's a plus and there was a minus. And just like with negative numbers, the way we handle the minus is we convert it to adding a negative. Now, the last version we're going to look at, it's going to be this. And again, we're looking for shortcuts to FOIL. We're trying not to have, if you kind of notice, there's a trend with these multiplications of binomials, is we can use the distribution method, we can use the column method, and then we could use the FOIL method. Maybe that speeds things up. And then for certain binomial products, we can even speed it up faster. We can use these formulas. So again, we're going to FOIL. We have first times first. So product of the first terms of the binomial. And then the outer terms of the product. The inner terms of the product, we're going to bring the minus sign with that b. It's going to bring the minus sign with it. And then it's going to bring it with it again when we do the last terms of the binomials. Now, if it helps, what you could do is rewrite this, and this is just for consistency's sake. And I think it's a helpful consistency. Again, because we have a minus, you can write it as adding a negative. So you can rewrite it like that. That might help it, make it a little more sensible. So this is our FOIL. So now we're going to get a squared plus ab minus b times a minus b squared. And again, a times b, b times a, they're going to be the same thing. A squared plus ab minus ab minus b squared. So negative times a positive is a negative. That's what we're looking at. And what you're going to see is that the terms in the middle they're going to cancel. And that's going to leave us with a squared minus b squared. And that originally was a minus b, a plus b. And the order here isn't going to matter. There it is. Sorry about that. Looks like the camera's sort of flickering this morning. You'll get the same thing if you had a plus b, a minus b. Any questions about that? So let me do a couple examples with this one. So let's say we've got this one. We'll get a little tricky one here. Well, again, let's take a look. Let's look for A and B. So here we have A. Here we have B. Now, in this case, for this one, we're not going to take, if we're going to use the formula, the minus sign's already included in the formula. So in this case, we're not going to include it. Now, if you want to be careful, and again, if you want to keep things consistent, you could convert this to a plus -6. And then you could FOIL this. Then you could FOIL it. And then you would get the correct answer. But in this case, if we're going to use the formula, we're going to go with B, and we're not going to bring the negative sign with it. So what we're going to get is A minus B, A plus B, and that's going to be A squared minus B squared. So the minus gets incorporated into the formula. Pardon that. Let me see here. Mute that tab. There we go. So A is 7y to the 5th. And B is going to be 6. And then that's pretty much it. We just need to simplify these and we're all set. So we're going to distribute our 2 as an exponent. And 6 squared is going to be 36. And when we're taking an exponent, and we're taking the exponent of an exponent, now 7 squared is 49. When you have the exponent of an exponent, you multiply. And that's going to be your answer. Questions about that? Again, the one that I think is a little tricky with this one, and to me it seems a little inconsistent. So you got to be careful. But when you assign your A and B, when you have an A minus B, A plus B, in this particular situation, for B, we're going to leave the negative sign off. So just something to point out. But any questions about that? All right. Now let's say we have something like this. Ooh, let me switch this up. Let's do this and this. So again, the order, if you have A minus B, A plus B, or like the one that we did before, we had A minus B, A plus B. I'm sorry, so you have A plus B, A minus B in this one. Again, whether you have a plus in front or if the plus is here, doesn't matter. So you can, these two expressions, you can switch the order on them. You could have 7 minus 6x times 7 plus 6x, or you can have 7 plus 6x times 7 minus 6x. So again, we're going to look for our a's. And then we're going to look for our b's. And for this pattern, again, the 6x won't carry the minus sign. Usually when we work with these, the minus sign gets carried, but in this case, we don't bring it with us into the formula. And again, this version of it is still going to be a squared minus b squared. So this will be 7 squared minus, and again, the minus gets carried for us into the formula. 6x squared. 7 squared is 49. And we're going to distribute this 2 as an exponent. And that's going to be our answer. Questions about that? All right. So that's basically it for section 4.6. Next, we're going to look at 4.7. Now we're getting to the last topics of the course, and this is division. So what we've looked at adding polynomials, subtracting them, we've multiplied them. We looked for shortcuts for multiplying them. Now we're getting to division. And the first topic in division is polynomial divided by monomial. Now, we've seen monomial divided by monomial. And when you have monomial divided by not monomial, you're basically sort of reducing things in the way you'd reduce a fraction in a lot of ways. And you divide, we'll do an example to bring that back. Excuse me, I seem to be kind of, I think it's allergy season, so I think that's having some kind of effect. But let's say we have this. So when we did monomial divided by monomial, we're going to divide the constants and we're going to divide the variables. And we could treat this like we have two fractions that are multiplied together, a constants fraction and a variables fraction. So 15 divided by 5 is 3. X cubed divided by x is x cubed minus 1. Again, there's an invisible 1 on this x here as an exponent. We get 3x squared. So we've seen this where we do monomial by monomial. Now we're going to look at polynomial by monomial, and we've kind of encountered this when we were working with equations for lines. We did run into some of this. And there's a little formula that we saw that kind of helps. If you have A, let me make this a little more universal. If you have A plus or minus B divided by C, that's A over C plus or minus B over C. Excuse me. And so we ran into this as kind of a little helper formula when we were solving, excuse me, for y. When we were working with lines, So what I'm going to do, I'm just going to give you a little derivation of why this is true. We're going to do the plus version of this. It's true if there's a minus sign also, but we'll just go with the plus. Excuse me. So let's say we have this. A plus B divided by C. Well, in algebra, we treat fractions like division. And it's been a while since we've seen this, but dividing by something is the same as multiplying by its reciprocal. Now, to see why that is true, so this is sort of a note within a note. You can treat A plus B over C as A plus B times 1 over 1 times C. Because you can always multiply by 1. It doesn't change anything. And so you can treat this as A plus B over 1 times 1 over C. And here I'll use dots for my multiplication since we are dealing in algebra. And then division by 1 doesn't change anything. So that becomes A plus B times 1 over C. So it's a little sort of math trick, and it's been a while since we've seen this. This goes back to that chapter when we looked at the number times its reciprocal is equal to 1. Any number times 1 will be that same number, that kind of thing. So now that we have this, and this is why it's true, what we can do is now distribute the 1 over C. And again, we're treating A and B as if we can put those invisible, well, they do have them, those invisible ones. And then if we multiply these two fractions together, we'll get A over C. Multiply these two fractions together, we get B over C. So what does this say? Well, at the very beginning, we started with this, and then we're ending with this. And so what this says, A plus B over C is A over C plus B over C. And this is going to be true whether this is a plus or whether it's a minus. Subtraction, you'll get the same result. So questions about that? Now, it's also going to be true if we have more than two terms, because we can distribute the 1 over C here to 2 terms, 3 terms, 4 terms, however many terms were in the parentheses. So this could be more than 2 terms on top. We could have all kinds of terms. So let's do some examples. Any questions about that? All right. So if we're going to perform this division, we're going to break it up where each of the top terms is divided by the same bottom term. And again, if there's a minus or if there's a plus, it won't matter in this case. So again, 5 divided by 5 is 1. X squared over x, 2 minus 1. 10 divided by 5 is 2. And then the x's cancel out. X divided by x, that's just 1. We're dividing it by itself. And the result that we're going to get is 1x minus 2. And then 1 times x is just x. And so we get x minus 2. Now we are making an assumption that in this particular case, x isn't equal to 0. So we don't get a division by 0. Questions about that? So let's take a look at another one. So again, we're going to break it up So each individual term is divided by negative 2a. So again, we're going to work with numbers, we're going to work with variables. So we could treat this as 12 divided by negative 2, negative 6. Then we have a to the 3 minus 1. And there's nothing, oh, I'm sorry, this b is not an exponent. It's just going to be b. So that's just a plain b. So we still have our plain b. Because there's nothing dividing into it. You could say 1 divides into it, but you don't have to put that in there. But you could if you wanted to. So this is negative 6 divided by negative 2, positive 3. I keep forgetting the b here. B squared. Now in this one, we have an a to the 2 minus 1. And then we have our b squared. And again, nothing's dividing into b squared, so it's just going to be there. Now this is 14 divided by negative 2. That gives you negative 7. The a's, they're going to cancel. They'll divide into each other to give you 1. And again, nothing's dividing into the b. You just get b cubed. And just as a reminder, don't forget, there's a regular b here, and this term had a b squared in here also. So negative 6a squared b plus 3. It's a to the 1, which is just a. But you could, since we did the subtraction, we'll put it there. 7b cubed. So the final answer and again, a to the 1 is just a. And so this is going to be our final answer. And we didn't have 2 terms, we had 3. So we broke up 3 terms. Excuse me. Questions about that? Now, sometimes things don't always cancel. That doesn't always happen. Let me show you an example of how that works. So in this case, again, we're going to break it up. We'll get a squared over minus 2a plus 2ab minus 2a. And then we'll have b squared over minus 2a. Excuse me. Now, for this, when we're dealing with the numbers, we don't have anything. There doesn't seem to be any number we can divide negative 2 into. But keep in mind, when you have a variable like this, it always has that invisible 1. So if you need to bring out that invisible one to do a division, you can do that. We'll do the same thing with b squared. So what this means is that positive 1 divided by negative 2, positive divided by negative, just get a negative 1/2. This would be a to the 2 minus 1. Now, 2 divided by negative 2 is negative 1. The a's will cancel, and there's nothing dividing in the b, so it's just going to do its thing. Again, with this one, positive 1 divided by negative 2 will be negative 1/2. In this case, there's nothing to divide in the b squared except a. So we could just leave it that way. And it's not going to simplify. It's just going to do that. So what we'll get is negative 1/2 a to the 1 minus 1 times 1 times b. If we multiply across, we're just going to get minus b squared over 2 times a. 1 times b squared is b squared. 2 times a is 2a. And then we can do the same thing here. We can put invisible 1 underneath the a to the 1. And a to the 1's just a. So it means we'll get negative a over 2 minus b squared over 2a. Now there's a faster way of doing this. So I'm going to go through and do it in a faster method. Because we tend to, when we worked with monomials, we would have a numbers sort of column, and then you'd have a variables column. I'm going to go through this a little faster, so we don't actually think of it in those terms. But if you want to think of it in those terms, you'll be fine when all is said and done. So again, we'll break things up so everything gets a negative 2a as a denominator. So in this case, what we'll do, there's nothing, you could try to divide 2 into 1, but since you could treat it like there's no stated constant. So we're just going to leave negative 2 down here. So we could do a to the 2 minus a to the 1, because a to the 2 minus 1 over negative 2 minus 1, these cancel, times b. And then this, there's nothing that's going to cancel or simplify. You just have a positive divided by a negative. So that's just going to be negative. And same thing with this, a positive divided by a negative. It's going to be a negative a to the 1 over 2 minus b squared over 2a. And then that'll just give you minus a over 2 minus b squared over 2a. Questions about that? So a little faster method, because when we worked with monomials, we would have numbers divided by numbers and variables divided by variables. And you can break out of that if you want to make things go a little faster. So let's take a look at one that's a little more complicated. So let's say we have something like this. Well, again, we're going to break it up. Each of the top terms gets the bottom term as a denominator. So if we simplify, excuse me, we'll get a squared minus 1, or b to the second minus 1. The c's are going to cancel, so just times 1. And then a's will cancel in this case. We get a 1. We have b to the 2 minus 1. And then c to the 2 minus 1. We get a to the 1, b to the 1 times 1 minus b to the 1, c to the 1, or a times b minus b times c. And that's going to be your answer. Questions about that?
Mr. Coburn, can you lift it down or push it down just a little bit so I can see that? There we go. More. Okay, right there. Right there.
No problem. And let me know when it's okay for me to erase this.
Okay, yeah, go ahead.
Okay. So here's another one. So again, we're going to break this up. Each top term gets a denominator with the bottom term. So here we got 6 divided by 6 is 1. X to the 2 minus 1. Y to the 2 minus 1. And then 3 over 6. That reduces to 1/2. The x divided by x, well, that's going to cancel. It'll just be 1. Y divided by y is just going to be 1. And again, we're assuming these aren't equal to 0. So you get x to the 1, y to the 1, minus 1/2, because 1/2 times 1 times 1 is just 1/2. That's a multiplication. We get xy minus 1/2. So any questions about that? So the last one I'm going to show you well, for now, the last one I'll show for this section. If you have others, if you want me to show more, let me know. Let's say we have this. Is it okay if I erase this?
Yes.
Yes.
All right. So if we have something like this, again, we're going to approach it the same way. So what we're going to do, same thing as before. 18 divided by 6 is 3. X to the 2m, well, this is the same as this, despite how complicated it looks. This is the exact same object as this object. So they're going to cancel. That's going to be a times 1. 24 divided by 6, 4. And then we're going to have x to the 4m minus 2m. 30 divided by 6 is 5. We have x to the 6m minus 2m. And so now we get 3 plus 4x to the 2m minus 5x, and then 6m minus 2m is 4m. And that's going to be our answer. Questions about that?
One more time, Mr. Colburn, just bring it down for me so I could see the whole, see if I can try to get the whole thing.
Just fits perfect.
Okay, I took a picture. You can erase it.
All right. All right. If you want to copy anything down, let me know. I can stop until you've got it all copied.
No, that's fine, because like, I can do it like how I did last time. Like I got your recording, like when you sent it to me, and then whatever I missed, I went ahead and like recorded it on for my notes.
Okay. All right. Well, no problem. Ooh. Well, that's it for 4.7. One last section. We've looked at monomial divided by monomial. We've had polynomial divided by monomial. Now we got to deal with polynomial divided by polynomial. So for this, and we're going to get an introduction to it this morning. We're not going to, we'll go through the whole process, but we'll do another on our next lecture on Monday. We'll go through a bunch of examples. But let's recall long division. Let's see. So I'm going to break long division down into kind of a longer process than what we're used to. But we're going to take this number 5. This number 5 is going to be doing all the work. It's going to be dividing in everything. So our first round is this. We'll take 6 divided by 5. And it goes in at most one time, at most. So it's going at most one time. And so let me do a little highlighting here. Make this blue. At most one time. So we put the 1 here. And then for the next step, little semicolon, we take that 1, we multiply to 5, and we get a blue 5. So that blue 5 goes here. We subtract, we get 1, we bring down the 2, and that's our first round of long division. Now we're going to repeat it. 12 over 5 is at most 2 times. Go to 2. And then 2 times 5 is 10. And that's going to be a blue 10. And that's 2. Bring down the 3. And that's the end of our second round of long division. Now we're going to our third final round. Take 23 divided by 5. It goes in at most 4 times. And if this is too small to read, please let me know. We do 4 times 5, and that's 20. We get a remainder of 3, and that's it. So we've gone through 3 rounds of long division. So our answer, when all is said and done, it's 124. And since we have a remainder, we add the remainder divided by this divisor. And that would be our answer. Now, technically, we would say it's 124 3/5. We would make this into a mixed number. But that's the idea behind long division. We're going to follow the same procedure for the most part when we divide polynomial by polynomial. So any questions about this? All right. Is it okay if I erase this?
Yes.
All right. So let's say we have this x squared minus 5x plus 6 over x minus 2. So what we're going to do is this. First, we're going to write this as long division. And for us, what's going to do the work is not the entire polynomial or binomial in this case, but just the first term. Now, what we need to do, we need to put these in standard form. So what that means, we want to have the terms with the highest degree first, then the term with the next highest degree, then the term with the lowest degree. Same thing with this. Term with the highest degree, next highest degree, lowest degree. This will work only if we put this in standard form. So what we're going to do is this. We're going to go term by term. So our first round, take x squared divided by x. And we're going to get a blue x. So we'll put the blue x over through the x column. This is like the x squared, the x, and the constant. And then we multiply this x times the entire thing. And when we distribute, x times x is x squared. X times minus 2 is minus 2x. And this needs to be, I'll do this in blue. Now, this is one of those things that takes, you got to kind of practice this to get the hang of it. And then we're going to subtract. Now, x squared minus x squared is 0. Now, negative 5x, subtract a negative this will become a double negative. So this becomes negative 5x plus a 2x. So we're going to get negative 3x. Negative 5x, what you're getting is this, minus negative 2x. And that becomes negative 5x plus 3x. So you got to be kind of careful of that. And that's going to be, I'm sorry, 2x. And that's negative 3x. So you kind of work that off to the side. Almost done. Bring down the 6. And that is our first round of polynomial division. Now we go for the second. Now this is going into this first term. Well, negative 3. Distribute the negative 3. We'll get negative 3x. Negative 3 times negative 2 is plus 6. We're going to subtract these. And since this is something subtracting itself, that's just going to be 0. There's nothing left to bring down. We're done. So the answer is x minus 3. It takes practice to get the hang of this. So if you're kind of looking at it like, wow, this seems kind of strange, don't worry. It's one of these things that just takes practice. Here, I'm going to do one more. And then on Monday, we'll do a whole class of working on these. I'm just going to be practicing them. So again, we're going to write it as long division. So again, we want to make sure it's in standard form. So the highest degree term is ahead of the lower degree term. Highest, next highest, smallest. And then the first term here is going to be doing all the work.
Quick question, Mr. Coburn. Is it always going to be set up like that? Like highest to lowest? Or like are we going to have to rearrange it at some point, or is that for next week?
You are going to have to do it from highest to lowest. You're going to have to do that. I don't think, looking at the homework problems, I don't think they're going to try to get you to rearrange anything, but that's what they're going to be looking for. For this to work, that's what you're going to have to do. So it's going to be like second degree. This is a second degree term, first degree term, 0 degree term. So you have the second, then the first, and then the 0. And then this is a first degree term, 0 degree term. So you want to put it in that order where the higher degree term is always to the left.
Okay.
So the first round, the A, and again, it just takes practice. We have a times this entire thing we'll get a squared plus 2a. Now, a squared minus a squared is 0. 3a minus a positive 2a, that's just going to be a single a. We bring down the 1, and we're done. That's our first round. Now for the second round. And we're always dividing the first term into the first term. So a divided by a is 1, positive 1. So we have a positive 1 in the constants column. Then we take that 1, we multiply it to a plus 2. And we get a plus 2. So now we're going to subtract. A minus a is 0. 1 minus 2 is negative 1. So we're going to get a remainder. And there's nothing else to bring down. So we're done with our long division. So the answer to all this will be a plus 1 plus, and then we take the remainder divided by the entire divisor. And we can rewrite this plus a negative. We can rewrite that as a subtraction. And that's going to be our answer. So any questions about that? We're going to do a lot more of these. There's some tricky ones we're going to look at next week, including if you don't have all the terms that you need. But we'll look at this next week. And again, if it seems kind of like, golly, this just seems really strange, it takes practice. It just takes practice.
And what section will we see this in? Because I know we have sections like so 4-3 and 4-4 tomorrow, and then Saturday 4-5 and 4-6.
This is 4.8.
Oh, okay. Oh,
so there's hopefully a little time. I can take a look at the schedule. If we need a little more time to work on this, we can do it. It's one of these things. I think you just got to practice it, and it could take some time to kind of, so it sort of sticks. It does take
right.
some time. Let's look at the schedule real quick. So it's going to be due next Monday. You've got some things on the weekend. So what I can do, I can make it due Tuesday of next week. 4.8 and 4.7. So it's going to be due the night before the test. And then that's going to be it. Then the test will be on Wednesday, final exam the following Monday. And here, Maria, I see your question here. I'm going to answer that question during lab. Let's see what's
Oh, okay. Yeah, I don't know why. I was like, why is it wrong? I didn't understand why it was wrong.
I'll take a look at it. I'll see what the, let me see. Look. What? Here, I'll have to take a look at that one. I got kind of a,
Yeah, okay.
Okay. Yeah, I'll take a look at this one. But that's it. Unless you have any other questions, let me know. Otherwise, I'll see you in lab in about 8 minutes.
Just send me the recording if you don't mind, please.
Oh, not at all. Not at all.
Okay, thank you.